is it spelled with ES or?
Yes, yeah.
Yes, so not Catholic. Is it Catholic but like it's complicated?
Well, like they're Catholic, but the spelling is not really. Cause okay, my mom was Torres on her dad's side, and her mom's side's Otero. So I don't know Otero, also branch. Yeah. You can just have a little history class, a little lineage lesson today.
I'm setting up some plans
Do you
here.
know any primaveras?
I don't think so.
Capola? Giardiello?
Well, I was. I don't think so. I can check probably, cause I know this guy. This guy's one of my ancestors, and he's pretty well recorded. Get out of here. I think he founded the Denver Post or something like that. I don't know.
Damn.
He's kind of a dingus though.
I'm assuming you know Bobby Duvall though, right?
I don't.
I told you that my grandma dated
Bobby
him.
Duvall.
Bobby Duvall.
Yeah. My
Not
grandma.
Robert Duvall.
Robert.
Bobby Duvall.
Robert Bobby Duvall.
Robert.
My grandma Rose Primavera dated him.
What?
Yeah.
For real?
Real.
Oh,
That's
damn.
so funny.
She used to sneak out of her job to go see Frank Sinatra.
Wow.
That's
So-
so funny.
That's another time.
Yeah.
That is cool. All right.
Well, doesn't tell me where he's from, so that's okay.
Okay, let's start business.
Yep,
Let's start
sorry.
business. You can keep talking after
I'm
this.
just
Let's get some business going.
Yep.
So, Monday, I know not everyone's, I know one person's not gonna be here. I don't know who else is not gonna be here. I'm gonna be here. You're not gonna be here either, Carmen. That's right. But it'll be recorded and it'll all be good. And, but it will be like something to definitely check out as ASAP after class. And I'm gonna do a handout assignment, so like a written one to turn in, and I'll get that to you too. I'll make sure that it's available and you can just print it out. And then several bonus web works will be coming for folks who want bonus things. There's not just one, there's multiple folks who want them, or should want them, I would think. There's people who want them, but don't need them. But there's people, but anybody can do them, but can do them. The thing I turned against extra credit like a long time ago because I would give extra credit, and then the only people who would do it were the people who didn't even need extra credit, right? So it was like I can't wait to get 130% in the class. It's like, oh my God, calm down, stop. So I'm gonna let you work on the web work, and I'll certainly answer questions. Let's just do a quick little check-in, little practice, pretend little karma-free quiz. I like to say, converge or diverge. Oh boy. Okay, I got a fun one. Okay.
That sounded
That did not sound good. I know, that was a little
Correct.
malevolent, possibly. No, shit, I won't do that yet. I'll do that on the take home thing. Hello? Yeah, okay. I don't know, I've been thinking about that -3 all day, and I think it needs to happen. That's not where I wanted it, sorry. I want n+1 on top and then 3 on the bottom, -3 to the end. So I'll write out what this series looks like. It looks like, I was gonna give you the like written out version, but that just seemed possibly cruel or something. Converge or diverge? You figure out the test. See if you remember the DEM rules. DEM tests. Whenever. I definitely just want to get it from you before you leave today. But what I was saying, you didn't even need 7 a.m. Like you've got so much credit built up in my mind and heart, like you're good. You got a lot of slack, Daniela. We haven't quite had one with like a negative in it like that, so it's a little bit different, but it's the same in a way too. Cool. Yeah, you're headed there. You didn't do your limit yet. Yeah, but that looks. So when you cancel these out, are you canceling them out limit wise or algebraically?
Algebraically.
No, I don't like that. They don't cancel algebraically.
Uh-oh.
But all the rest of the stuff looks pretty good. And then you still have to take the limit loop.
Mm-hmm.
And a little more algebra too. Not that. Yeah. When n is super large, when n is 1,000,000, what is that fraction, roughly? Yeah. Right? Or you could L'Hopital, because it's an infinity over infinity. Yeah, or that polynomial rule I gave you. They're both polynomials in n of the same degree. So leading coefficient ratio. I saw Olivia walking the other way, and I said, "Are you coming to class today?" And she said, "Oh yeah." Guess she's still good to come to class. Doing lots of good work. So that's encouraging, definitely. Yes, except for the absolute value.
Okay, that's what I was gonna ask.
Yep,
So
yep.
it's just
Correct. Yes. And then, yeah. And so then you can conclude. Yes.
yay.
Thank you, everybody who's using the ratio test. So that is really, it warms the cockles of my heart to see that. And so we're gonna create, and so an plus 1, here's a sub n. So an plus 1 is just this. And then the reciprocal of that is that. And I saw that a lot, so that's awesome. And then things got a little weird. So let's talk about this. So the n plus 2 over n plus 1 is going to be really the only thing that's variable and left in here. And there's one more -3 down here than there is above. And so the absolute value of that is 1/3. So don't forget to take the absolute value. Otherwise the test will be baffling, right? Yeah, because you'll be like, well, wait, I'm supposed to check this. You know, what about negative? So that's why you got a negative, if that's the case. And then this limit here, ratio of polynomials in n, same degree, 1 to 1 goes to 1. You can L'Hopital that sucker once. You could just plug in a giant ass n and see it's 1,000,002 over 1,000,001. Either way, you conclude 1 and you get 1/3. So this converges by the ratio test. Yeah. So the exam, our final exam is going to be a lot of this kind of stuff. And we're going to practice, we'll practice one every day no matter what we do. But we'll be doing a lot more. This is also called, notice how this one alternates, it's plus, minus, plus, minus, plus, minus. There's actually a very special test for that called the alternating series test, which you don't have to change your notes. But there's a very special test when a series it alternates, and it's super easy and wonderful. So we'll talk about that on Monday. And then the week after, when we come back from break, we're going to be doing power series. So we're going to be looking at infinite polynomials, and I can't wait. It's so exciting. It's hard to not talk about them earlier. That's why I had to talk right away when we started. So anyway, finish up the web work. If you're done with the web work, do as you see fit.
Can you go over 2? Let me pull it up.
Okay, I need different glasses. Let me get it.
No, my brightness is super down.
It looked pretty low. Looked pretty dim. Well, now it looks pretty good.
Well, now I have a pop-up virus, but there you go.
That's good. Well, just hide that. You did come, just like you said. Yay.
I think I meant 3. So I was like so confused by this. It's like,
Oh, okay. So what's confusing you?
so, their first term
Yeah.
is x minus 1 to the power of 2. So it increases by, so 2 times 2 is 4.
Mhm.
4
Mm-hmm.
times 4, wait, 2 plus 2 is
Yeah.
4. 4 plus 2 is 6. 6 plus 2 is 8,
Yeah.
right? So that's n plus 2.
So I would recommend, your thinking is totally cool, but it's not gonna help you,
Yeah. no.
like with this. So let me give you a little pointer, if I may. May I borrow this really quick? Thank you. This is number 3 that Lou is asking about, which is actually kind of challenging, I think. Oh, Olivia, just make sure to check that stuff out. So in this one, we have this series, and you have to fill in 2 parts. You have to pick a starting index, and you have to pick a general term expression. And there's lots of right answers for this, and your answers just have to be consistent with each other, because there's 2 blanks there. So the first one is, oh wait, I better put what the damn series is. So this is loose series here. I don't know how much variation there is in this. 2 factorial, x minus 9 to the 6th. I'm going to be, it says 16 here, I'll go ahead and write that and then talk about it. And that's that, we can get by with that.
Thank you.
Yeah, thank you. So we need 2 things. We need an expression and then where our index starts. So what I would do here is kind of line these up. So Lou was originally looking at patterns here, noticing there's an increase by 2 on the x minus 9 part, you know, it's going up by 2, which is completely true. But I think a more useful thing to do here would think, here's 1. Yeah, I would either let n start at 0 or 1 and work this out. So let's say n starts at 1. And then this would be n equals 2, and then this is n equals 3. And honestly, I think there's gonna have to be tweaks that get made no matter which of these 2 you start at. But from here then, how do you relate that exponent on top to the, oh, she's, my God. I was like, wait, this is much harder. It's only harder because I can't count to 3. So, that's my problem in life. I've just been stuck at 2 forever. So I think that once you do this, you can actually kind of see a nice relationship between the index and then that exponent. Do you see what I'm talking about, Lou?
Mm-hmm.
Like, so, yeah, like that the exponent is twice these things, right? But then here, this one doesn't have a fraction. So notice that this is 4 to the 1st, and then what is this in terms of 4?
4 times 4.
Yeah, so 4 squared, right? And I would use exponents, but yeah, 4 times 4, absolutely. Next one's 4 cubed, because I think there's a 64 next, is that right?
Yeah.
Yeah, so 4 cubed. So how do you relate, well, what do you think I could put here to make it kind of like that? Or, well, you're not, yeah, let's just, you're jumping to the answer, definitely. But I could put a 4 to the 0 there, right? Just to try to like get the, yeah, that's gonna be it, but yeah. What about in terms of factorial?
1 factorial.
1 factorial. So now do you kind of see how you could get a pattern going on that one?
Mm-hmm.
That's what I would recommend to do. Just get those indices written below and look for the relationship between the index and the different pieces. Yes.
I don't know if I typed it in wrong, but I have this, and it just says that it's the wrong value.
Well, let me take a look. Okay. Do I do a preview on your answers? Oh, is that your, that's it right there? Jeez.
So I
Oh,
don't know
no,
if you started it
what,
at 0.
so what are
or-
you starting your index at?
Oh my goodness gracious.
There you go.
Oh my dearie.
Goodness gracious.
Oh. That makes
There you go,
So
there
much.
you go, yeah.
wow.
Yeah, that was pretty complicated. Your answer was really complicated. What's the fanciest way to write 1?
You know, I was like, the first term, that's what it wants. And that was not what it wanted. And
That is correct.
What did it want?
a number, a single number.
Just the,
all
just the
close
lower
up.
index. Where's your,
1.
there you go, for that picture up there,
It's
yeah,
not
for
working,
sure.
and I did not
Well,
want it one.
That may not be because it dislikes you. Well, you don't have any answers in there.
No.
It's like they're blank. Lou,
But then I
it
put a
can't
1,
read your mind.
and then it's incorrect.
Well, let me see when there's actually answers,
Okay.
please.
Good
How you
idea.
doing, Carly?
Yeah,
Good, okay, all right, good.
it's not easy.
It sure ain't.
She's
doing.
I'm not having a great time.
You're not having a great time, okay. So, So what are you thinking here? Like,
I have no idea.
okay, let's see, where's your write out of all this?
I didn't write it out.
Well, let's write it out. I'm having trouble because I can't do this in my head. Oh, I'm sorry. Yeah, the write out, yeah. Yeah, there we go. And it's actually the kind of the same one except for a 7 instead of a 9, right? Okay, so make those adjustments like we did. How did we modify that first one? Yeah, all right, good. Now, put a 1 under here, 2 under here, and a 3 under here. What is the relationship between this to this? How do you move from that to that? I want you to think about it a little bit, but like, what would be, look at smaller pieces. I think you're trying to look at it all at once. How do you just move from this to the index? Like, what's the relationship between the index and that number down there? Or excuse me, the exponent and this number down here. Times 2, right? So if this is n, what's the exponent? In general.
2.
Well, if n is 1, absolutely. When n is 2, it's this. So you need to put this in terms of n, just like we do in general, right? We want that general term there. So if I said to you, let's actually try this. What would be the 4th term? Let's see if we can just do that. What's the 4th term look like? Okay, what's the 5th term look like? So, beautiful, that's perfect. So, what if it's n and not 5? Do exactly what you did to get here, but use the letter n.
I have no idea.
How did you get from here to there? So first off, let's get the basics set up. What did you do to get that exponent?
Times 2.
Do the rest. Think about it. Take some time. Think. No wonder you can't think. You're drinking Sprite. There's no caffeine. That's good. That's good.
There's nothing funny.
All right. How are you doing? Oh, wow. I just saw. Yeah, beautiful. Okay. Showed up just the right moment. How are you doing? Everything good? Okay. What do you want to talk about? Okay, where's your stuff you've written out to think about it? Write more. I'll be back. How you doing? Just get more back up here. Okay, all right. How you doing? Everything good? You got something you want to talk about?
Yeah.
Yeah, okay, okay.
For this one.
Mhm.
We can do the limits equal to this.
Mhm.
Then we can use the.
There you go, exactly.
So we have to use another.
Well, you don't have to do anything for this problem. You're right, in real life you would, luckily. So, I like the way you're thinking, yeah, you're done now, good job. That's a quick one. Oh, look at all that. Is this helping? So, let's see, what do you got so far? Okay, so the top is definite, that looks really good. I would put the 3n in parentheses, because otherwise it's just cubed and then times n. Does that make sense? Yeah, so, okay, cool, that looks good. Got one more challenge. what was, and there's no exponent, or there's no number down there, right? So that's the tricky part. Yeah, let's write out that last one. Can you write this one out just really quick? Because I think we need it, actually. Cool. Okay, so this number here, how do you move from here to here, and then from here to here? Just with the 3 to the 9, and then the 9 to the 27. Do they have any like relationship with each other? You multiply times 3. So these are powers of 3. And what's that? So what power is that? Yeah, and then what's that? So I would rewrite them like that to help like gather that, you know, that rhythm. And then that's 3 to the 3rd, right? So what's the relationship between the n and the exponent here? Is this 3 cubed? It is not. So it's 1 less than the n, yeah. And then this thing right here, you lucked out, right? That turns out to be just exactly that. What would be here in terms of 3 under that first term? Yeah, and then times what factorial? See? Okay. All right, Cassie, how's this going? Did you get it?
No.
You're moving on. All right.
Yes.
All right. Okay. Let me know if you want to come back to it.
Okay.
You know, I know, it's just not, here's my doing.
Oh gosh, what's going on? Let's see. Oh, okay. Yeah.
So the way she has, and then I did the,
Ooh, this is a hard one.
it's really weird.
It's tricky. Like shit. I put that in already. Okay. All right.
So, this is n plus 1, where here's minus 1, so it just cancels all the ones right away. Cancels the ones right away.
Mm-hmm.
No?
They don't cancel
I can't do
because
that?
no.
Because it's 4 times.
Yeah.
Oh my.
Let's
know
get
what?
you.
I
We're gonna hook you up with some
can't
caffeine. You don't drink caffeine either, do you?
I don't drink.
You're all smart. You're all much smarter than me.
I mean, obviously not if I can't count 4, so.
Well,
Sometimes
I got stuck at 2, so you're twice as good as me.
Oh goodness. Wow, this makes math so much easier when you can count.
It really does.
Sorry, my hiccups are really loud.
Oh, here, I heard this on TikTok. So we evolved from fish at some point.
Oh my
And
God.
did you hear this? I want us to try it.
What
Let's
is
try it.
it?
Let's try this.
Why do I feel like I'm gonna be scared?
You shouldn't be scared. So we, at some point, if you believe in evolution, we came from fish. And the hiccup is a remnant from the fish days. So tell yourself, just remind yourself you're not a fish.
Okay.
Just do it, like in your head, think, Kendra, you're not a fish.
Fish are smarter than me.
I mean, I'm not hiccuping, which is really weird, but
Wait, is that how you get rid of hiccups?
That's what they
just say
say.
you're not a fish.
Just remind yourself
I
you're not a
thought this was
fish.
to help with like, yeah, you got this, you can do math, you're not a fish.
I'm gonna put up for our next test. Just write, "You are not a fish."
Absolutely.
Encouraging
I think it's gonna be like a tagline.
It worked, which is really weird.
That's this insane. Cassie saw this too, though.
I don't.
Have you tried it outside
No,
of this?
I
Weren't
haven't
you
had- I
excited
haven't
to
had
see
any
though?
hiccups.
Do fish hiccup? Like, I don't understand.
I guess. I don't
But
know.
So odd.
Was the first fish out of the water.
What was?
The Tiktaalik.
Tiktaalik?
Yeah.
Had the little feet,
Little feet.
little
yeah.
flopper feet,
Yeah.
flapper feet, flapper feet.
A very, very brave creature.
Yeah.
Braver than I'll ever be.
I think you really need to stop comparing yourself to fish. I don't think that's
Their
good for
brain
you.
works
Self-esteem.
smarter.
I mean, there's nothing wrong with fish, right?
I
But-
mean, there's something wrong with dolphins.
What?
You make an excellent point. Dolphins are a little scary.
Dolphins?
Like dolphins, octopus, and elephants
They freak
all
you
have
out.
like morals. They know what's right and they know
Yeah,
what's
I
wrong.
believe that.
They are very sexually aggressive and they will assault people.
I've
is
seen
true.
that.
Yeah.
Yeah.
They're not
Kinda
cute and
not.
cuddly like you think they are. Preferably stay away.
We should definitely just be leaving dolphins alone in general.
Yeah, that's a fair point.
Yeah.
Facts.
Oh, the conversations of calculus.
Makes it better because it's recorded.
Are we recording?
Oh shit. Yeah. This is gonna get posted too. I'm posting this one. I got to.
That's why I picked my words carefully.
My mom's gonna ask, how is school going? Here,
And
watch this
Cassie's
video.
like always visible too. You're like
Yeah.
the one everywhere you can see.
I feel safe off screen.
What?
I'm nice and safe off screen.
Oh. Yeah.
I'm not worried.
Danielle, did that one work out?
Yeah.
Okay, awesome. Yes, ma'am. Okay. Okay. So that is not Ace of N, and that's probably the problem. That's part of it. It's definitely part of it, but Ace of N, and this is the one Kitra was working on, is this whole product. Let's actually talk about this one together, because I think other folks think, is this okay? Yeah. This is, what problem is this? Number 8. Number 8 is one of the harder ones, I think. In this, we have some. Maybe I'll actually create one like this. I don't want to do this one in particular. That's dot, dot, dot. So that's a big, weird product. So it's like a factorial, but not. Yeah, it's quite strange. So converge or diverge. Definitely ratio test is good. But let's take a look at what the general term is here. So this is literally Ace of N right here. So Ace of N is this thing. That whole product. And I'm gonna actually, this is where I was suggesting writing out what these things look like, just a few terms. And I'm gonna do that in just a second here. So Ace of 1 is when N equals 1, and that's just 6/7. So Ace of 1 is just 6/7. Each time you're actually adding one of these pairs onto the top and the bottom. So Ace of 2 is 6 times 13 over 7 times 15. Ace of 3 is the triple product on top and this triple product in the bottom. So Ace of N is N of these things all put together. So it's a big, long, kind of hard to express product otherwise. Ace of N plus 1 is where the challenge comes in. And what you need to do is replace that N with N plus 1. And here's the trick, Vivian and anyone else who's watching, I know Kitra is for sure. This part will be there. So this part's gonna be there, and I'm gonna add the next term on. So this is all there, times 7 times n plus 1 minus 1 over 8 times n plus 1 minus 1. Does that make sense? So this is the an plus 1 term. And it includes this. So that's really nice. It's kind of like I said, it's like a factorial, but it's not. It's a little stranger than that. So when we do an plus 1 times 1 over a sub n, it's going to be this thing times the reciprocal of this, and all this stuff is going to cancel. And so Vivian, it'll actually kind of end up looking like what you had, but you got to get there with the right route. You know, does that make sense? Kind of. Do you see? Do you buy this stuff here?
Like I don't get why you add the 7 or like the variables.
Because this index here is that same as that there. So if I put 7 in there, I'd put 7 in over there. But here I'm putting in n plus 1, so I've literally just replaced this with n plus 1. But you need to understand what's happening here is that right before this one, n equaled, or this thing in here was 7n. So right in front of this was 7n minus 1, and right in front of this was 8n minus 1. Yeah, is that, yeah? So then when I can do this one, and you got to do a little simplification here, right? That'll be 7n plus 6, yeah, 8n plus 7. Does that make sense? When you simplify these out here. Then like most of this stuff is going to cancel. Yeah. And you'll just be left with these pieces. So that's a very challenging one in a way, especially at this stage of the game that we're playing. But your intuition was right, ratio test for sure. Come around the restroom, I'll be right back. Did that work out? Awesome. Kathy, you want to talk about that one again, or no? Okay. Okay.
just gonna ignore it.
Okay. No, no.
I'll do it later.
Okay, okay. You okay over here, ladies? I can.
I don't know.
So why are you starting the index at 6? Just like, let's just go through what you're doing.
Oh, the index.
Yeah, yeah. So we need to come up with a formula here, right? And so what I would do is, do you got some paper I can write on? This is the best thing to do, to write out your series. And underneath it, write the indices that are gonna correspond to it. So this is gonna be your n value. You need to figure out, how do I move from, like, come up with a formula. How do I move from here to here? And then it becomes a little bit more apparent what n needs to be, right? So up here, you need to put a formula that'll give you any of these when n is that value. And you can see some things are gonna be, like the 6 isn't changing, right? And then the bottom, if there's not a fraction, what do you think that fraction could be? Yeah, there you go. How's it going, Lou?
Well, I think I'm like count that.
Let's see, can I see the original again, sorry?
Yeah.
Oh, yeah, okay. Now let's zoom back in, okay. Oh, it's this shit up here, the one I erased, okay. Yeah, yeah. Okay. So where are you gonna start your index at?
1.
Well, let's try that. So if you put 1 here, then when n equals 1, what's the exponent here?
3. So we
Yeah.
want that's gonna be 0.
So now what's the exponent?
2.
Cool. Then the next exponent, then the next value of n would be 1. What would that give you?
3.
Yeah, that ain't right, is it?
No.
So, looking at, let's do this, and I don't see you writing this down, and I want you to definitely write it down. You've written a lot of stuff down, absolutely, I'm not doubting that. But you're not writing down the thing that I think is gonna help you the most. Let's do one more. It's 4 squared, we agree with that, right? Yeah. Put 1, 2, 3. You need to figure out what is the leap from here to here. So let's look at that exponent. How do you get from that number to that exponent?
1 times 2.
Yep.
2 times 2.
There you go.
3 times 2.
So it's not n plus 2,
It's 2
but
times.
there you go. All right, nice. Excellent. So now, well, yeah, we've still got a few things to tweak.
Yeah.
That's better. That's definitely, yeah, that's definitely better. But we've got some other things to fix. So we're starting at, and we want to start at n equals 1
Okay.
now, right? Does that make sense?
Yeah.
So, because we want that 2 there. So if we're starting at n equals 1, what do you want the power on the 4 to be here when n equals 1? Let's just,
You want that,
yeah, let's put it under there.
you want this down here to equal 1.
Want it to be 1, so what would that power on the 4 have to be?
0.
So write 4 to the 0. And then what's the factorial gonna be there?
That.
2 factorial would be 2. In fact, there's a 2 factorial right there, and it's the next term. So what is our first term? So check it out. First term, second term, third term, fourth term.
First term is gonna be 1.
There you go. There you go. So how does this, so when it's the first term, the exponent is 0. When it's the second term, the exponent is what there? What's the
1.
1. What's the relationship between the index and the exponent?
N plus 1.
So you're telling me that, you can see that, just like me saying that, but n equals 1, n plus 1 is 0.
Zero plus one. 1 plus 1. If we start at.
Yeah, if you start, so that wouldn't be right, would it? How do you move from 1 to 0? How do you move from 1 to 0?
Minus
There you
1.
go, there you go.
So it's-
No, so n is 1, there you go. And
Then
then,
there's gonna be 2 minus 1.
does that make sense? Because the next one's 4, does that make
That's
sense?
gonna be n.
You can put parentheses around that whole n minus 1, because that's a quantity to itself. There you go. And now let's look at that n plus 1 factorial. When n is 1, what factorial do I want? What was this? Yeah, yes, exactly. And then here, when n is 2, when n is 3. So we don't really need to add 1 to it, do we? Because that
So
would be,
it'll
yeah.
just be n?
Try that.
Well, it's just so much to keep track of.
Just like, so the thing to do is bit by bit, the way we were talking about it, right? Look at each piece separately and think of it as a separate problem. You know, don't think about this. Think about that first. Then think about that 4. Then think about the factorial. Just make it multiple problems. That's the way to do it. Doing good, Carly. We haven't talked at all, but you're rocking it.
Yeah, I just noticed I did something wrong, so I'm going back.
Okay, cool.
Try it.
What you're doing there looks good.
Yeah, so the rest
Actually,
up here.
yeah, because that's, yeah, I was gonna
That's
say.
why.
Okay, gotcha, that'll do it,
Next one.
that'll do it.
What?
This is multiple parts. This is weird.
Let's start with one part at a time.
And then
Oh, I know, let's fix it one part at a time. Let's fix it, so.
It said it was right.
What?
And then I clicked the
What?
next thing and then it told me it was wrong.
Huh? How can that be?
I did this.
Wait, where are we
I
at?
submit it.
Okay,
Correct.
okay,
I didn't say conversion, it was
okay,
go on to the next part.
okay. Oh, I see, I've never seen a problem like that, how strange.
That's
Oh,
weird.
so you have to like solve the next part to get everything right.
And then otherwise you have to go back and,
Most impressive
that's pretty bad.
test is,
So it's gonna set the first part is wrong, but you have to solve the next part to
Okay.
get everything right.
Okay.
well, I mean, it's literally just 1 over some variables, so probably P series.
So what is it, wait, what is it asking us? This ratio is? So,
It's 1
so
over
P
K to
series
the
isn't a
7th.
test. It's a thing we use in the test. We use that in the comparison test. So let's see what are our options here. If the ratio test was, so I would try the limit comparison. That's what you would use the P series.
And then I
with.
would just put in the,
The appropriate P series. But
This
hold
is-
on, this is like,
it's 1 over K to the 7th, so it had us put it in.
oh, okay, I
through
see.
the ratio
Yes.
test, you get this answer,
So that's the limit,
And so then it's
got it,
saying-
I see.
because
Got it.
of that.
So the next thing would be limit comparison test.
I see.
And it would,
Because P series.
it would actually converge, yeah, cause it's like
Then
1 over P to the 7, or 1 over N to the 7. Dude, what? Try your P series.
It might just be
It's-
picky and weird.
That's weird, that's dumb,
Yay.
that's not a
did
test,
it.
but whatever.
But yeah,
Which problem is that?
number 10.
On number 10, the second part, they want you to say P series.
Yeah.
That's dumb.
There's also that little
That's not a
check mark,
test.
checkbox thing that you had to
Whatever.
click to get to the next part, which was strange.
Okay, whatever.
Yeah. But yay!
Oh, maybe it was the actual problem a P series? Oh, that's what it is.
It was just 1 over K to the
Okay,
7th,
then it
yeah.
is a P, okay, then, all right, they're not complete idiots, they seem.
Where are my unread emails? I just sworn I did them all. Yeah.
Oh, That's okay, no, you're fine. That's great.
So,
What is the ratio test is, oh, you haven't selected an answer for it, right?
no, for this one,
Okay.
it's supposed to be push,
Oh, okay. So the ratio test, yeah, that is because that is converge. So your R is 1/9, that's less than 1, that's converge in the ratio test. Do you have that sheet?
But it says the answer is diverge.
Oh, the 9's on top. Oh, that's because, oh, your 9 should be on top here. That's the problem. So, see, there's one more power of 9 on the top than on the bottom. So this is actually 9/1 in the front, not 1/9. And that's big. So this should be 9, not 1/9. Yeah. So that's the problem. So yeah, you're doing everything great though.
Oh, but,
Yep, uh-huh.
also, or just,
Yes.
like, this is the.
Oh, Lord, yeah. That's okay, so let's think about. Wait a second, no, this looks a little weird. So, yeah, so this should actually be a times here, not a plus. Because it's that times that, so there's no plus in the bottom.
Well, because time it.
Oh, you distributed, I see. Okay. So, what is the essential highest power of n in the bottom? Like pretend this is just square root of n. Let's do the top first. So you've got an n squared as your highest power here, times the square root of n. What's the net effect of that? So it's like n squared times square root of n. What's the exponent of that?
X squared times.
Or n squared times n to the 1/2. Yeah, 5 halves, actually 5 halves, I think, but yeah, you're thinking the right way. And they have, so like on top, you've got n to the 5 halves, and then on the bottom, notice how you've got n plus 1 squared, so that gives us another n squared times that root, so that gives us an effective that.
So that's the same.
Mhm. Yes. Does that make sense? Yeah. Have a good weekend.
Alright, have a good break.
Oh, thank you. Oh, yeah, break. Oh, yeah, see you
Yes.
afterwards.
And since I won't be here on Monday, I look for the worksheet thing,
Yes.
and it will be posted when?
Soon, I don't even have it written yet, so
Okay.
by Sunday-ish, Sunday, the latest. Probably Sunday afternoon.
Okay. I'll probably handwrite it, because I won't have access to it.
No, don't worry about it, it's all good. Okay, bye. Oh, yeah. Can I see your work for this one? Okay. Oh, we haven't taken the minute. So let's simplify. So what's left over is that over that. So let's simplify that really quick. See, Carly? Yes, just that. Yeah, so, yeah, perfect. That's exactly what it is. Let's simplify a little more. There's one more step. Where does that go to as n goes to infinity? What's the top doing? When n goes to infinity, where's the top going? Let's just look at that, please. Yep, and then what's the bottom doing? All right, so what kind of ways can we find that limit of infinity over infinity? What's the derivative of the top with respect to n? We can do this. Yeah, there you go. Perfect. Yeah, that is the answer. Good job. How's it going, David?
Pretty good.
Yeah? Okay, cool, yeah.
We got a.
You're doing good, yeah, good. So, just like, kinda like that up there.
Okay.
That's your friend. I can't hang out late today because I have to go give a presentation at Senate.